Hello everyone. I'm dealing with a really annoying bug, so I'm just gonna take you along with me. I thought it'd be interesting. All right, so I'm using FreeRTOS, trying to make a little music player, trying to stream some data to it. I'm also trying to decode the MP3 frames and turn them into PCM16. Then I decode them I transform them into PCM8 unsigned, and then I shoot that over to my DAC over here. I'm doing a little experiment where I put the data that's going to be streamed to the DAC over DMA into a different RAM block. There's the initial main SRAM for the chip that I'm using. In this case, I don't want to use that main SRAM because I think it's getting in the way of the MP3 decoding at the same time as streaming audio, which is causing clipping and other issues. But for some reason, my code just keeps failing. I'm on debug mode right now, and for some reason, it just will not do. So I'm going to show you a couple of the things that I do to kind of figure this stuff out. Whenever I get this low level, it's because I can't see any logical reason for why I'm getting this error. It might be something logical, but I couldn't find it. First things first, look at the assembly. I'm basically breaking here. For some reason, when this function tries to return, the value for R4 is not preserved. I'll show you that in a sec, but check this out. So I'm gonna put a breakpoint at this spot. All right, let's delete all my breakpoints, and I'm gonna put a breakpoint here. Ooh, I need to pick that as hex. So you can put a breakpoint directly on an instruction. Really helpful when you're going at that low level. I'll do the same one here so I can see what it looks like at the end, and then we'll look in between to see why things get messed up. It might just be at the start. And then 0 hex, boop. All right, and then I'm gonna do monitor reset halt to reset the device. Press continue, and oh, what happened? I think I'm disconnected for some reason. Let's reconnect. I will reconnect this way. I'm in there. That's fine. Breakpoint. I lose all my position, but that's fine. I can just do this and breakpoint asterisk and one reset halt. Go back. All right. So now we're here. I need to change the layout to split mode so I can see the assembly. All right, and then Control X so I can get to where we are. That's synth. Where's granule? Let's type in list. There we go. Cool. All right, so we're at this instruction now. Yeah, let's just check out. Let's print the state of R4 and let's do it as hex so we can see if it's anything reasonable. Oh, I'm in the wrong spot. Let's do there. And in order to change the window, so I'm using the TUI, the text UI in GDB. There's like this thing that's way better called the GDB dashboard. I absolutely love it, but I can't use it on Mac because the GDB for Mac that I'm using for this for the ARM GNU toolchain doesn't come with Python installed and built with it. I think 13 does. I'm using 12 right now. I asked them to make sure 13 would include it, but I haven't checked, so I need to do that at some point because it'd be so much nicer to use theirs. Regardless, let's take a look at this. All right, so R4 at this step is the correct value. This is actually within RAM. I know this number from before. That looks correct. I'm actually curious what R5 looks like. And R5 looks like, sure, that seems like a reasonable number. Yeah, seems fine. All right, so now I'm gonna do next instruction. Now what I'm gonna do is I'm just curious, what is R4 now? It's the same thing. What changes R4 in here? Like, all right, so it moves R2, which probably has the parameter for R2 will have like, this is the first parameter, second parameter, third parameter, and then fourth parameter, and it might be getting more parameters from maybe from the stack, if they're loaded on. 1, 2, 3, 4, 5, 6 words. Yeah, you can't hold that all in the 4 registers in the ARM ABI. So yeah, so these aren't being, so these got used and the rest is on the stack. Okay, cool. I assume after this step, I'm going to see what happens to R4 because for some reason the stack itself gets messed up. I'm not sure why exactly. So I'm just going to go next instruction all the way until I hit R4. Let's see what R2 is. I should see what R4 is now. It's 12. That makes sense. That seems fine. And actually, I'm curious. I skipped over those 2 steps. Should not have done that. I was wondering if maybe the variables on the stack were messed up somehow, because when I go to the end here and then I print what's like R4 is fine. Like this is just a typical 12. It's 12 like it was before. Something crazy there. The problem is that when I print, I should have done this before. I'm going to do uint32x. I'm going to cast the stack pointer register into an integer. Then I'm going to dereference it. Cool. So this is the value so this right here is doing a pop. It's popping. It's taking the stack pointer value and it's going to pop back R4 and all these other registers back into the respective places. When it hits PC, it will basically return automatically up one layer. The problem is that for some reason R4 was like 1,519 5190 hex. That was the address of one of the variables I had, and for some reason now on the stack it's this. And then the next one after that would be R5, which was this value, and then there's this, and then you keep going. And if we go up to 7, because there's like 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So if I do 7 here, which is it's 0, zero indexed. So if I put 7, that'd be the 8th element in here, and 26C3. Well, 26C3, C2. Yeah, there we go. Cool. ARM sets the LSB whenever it jumps. I think that's for like to detect that whether or not you jump to the wrong location inappropriate. I actually don't know why they do that, but yeah, cool. So this is right after that function call. I'm actually within this depth. You can see that when I type in where that my previous function, I just looked here, 26C2. Yep, that's the return address. So the stack is fine except for R4. For some reason, R4 has been corrupted in this function. And it might be because there's a bug in this function, which would suck. But yeah, so that's a thing. I don't know why it's getting corrupted though. I was thinking it might have been something that I did, but maybe not. I don't know. But yeah, check this out. So I do next instruction, boom, hit back out here. Cool. So then I'm going to do next instruction. Check this out. So this is dereferencing R4, and it wants to be 8 bytes, or 8 bytes ahead, and then it's going to load that into R3. And I think that's going to do this last part of the PCM plus whatever this thing is, because that granule synth was the last function in the for loop, so we're jumping back, we're doing this part. But check this out. So if we do print R4, oops, wrong one. Look at that. I can't dereference that. That's not within my space. That's not going to work. So this is where my seg fault happens. So if I do next instruction after this, boom, I'm in my hard fault. Makes sense? That's logical. I do not know if there's anything about what I am passing in that is causing this particular bug to happen. Like I got this variable, he's on the stack, but I mean, it's fine for him to be on the stack. He's small, it's not a big deal. We're not, I thought I was blowing my stack somehow, so I kept making my stack size bigger, which I think now I can make this guy, I don't know, it's 512 probably. Yeah, we'll see. But yeah, that's not my problem. It seems to be something deeper in the decoding library. I'm not exactly too sure where exactly. Wait, hold on. What is all this? Oh, it's all darked out because it doesn't know what macros are being used. Wait a minute. We are actually interesting. There's this MP3 only, ifdef MP3 only. Do this, and then what is the ifdef for this area? Okay, this actually is normal code. Okay, so gotcha. Yeah, so this is okay. So I'm layer 3. I'm doing MP3 decoding, so that's why I'm here. It's a little grayed out. Yeah, for some reason this particular function seems to do something weird. Doesn't look like it's weird though. It looks like a normal function. Understandable but logical. Like, I'm curious. Is there anything here I can actually spot that looks like it's corrupting the stack in any way? I mean, this is the PCM sample that we had before. Yeah, maybe there's some sort of like stack overwriting happening here, like an off by 1 somewhere, that's causing all of this issue. All right, well, last thing I can do is basically see at what step in the code this actually has that problem. So we're gonna reset again and go back. Oh man, I wish, the thing is if I had the GDB dashboard, it would already show me my registers. here. Actually, I'm gonna look that up. Show registers GDB screen. I don't know. Maybe Google's gonna give me something nice. Maybe, I don't know, or it'll take forever. Info, registers. I mean, I could keep running this all the time for every step. Kind of annoying though. Alright. Yeah, that's super annoying. Alright, well, I don't really have much more to do than simply just jump, print R4, oops, R4, okay. Wait, no. Actually, I don't check R4, I need to check the stack pointer, which I think I can do by looking at this, because it should be, yeah, perfect. Next, I, did I break it? Nope, next I, did I break it? Next I, did I break it? Next I, did I break it? Okay, I'm just gonna go after this, see if anything's changed. Nope. After this, anything changed? Nope. After this, okay. That one a couple times. Still no change. Okay, still no change. Okay, still no change. Okay, that's good. What could be breaking? Maybe it's this thing. If def, non-standard but logical. Okay, maybe I have something non-standard, and let's copy this bit of code here. It just hasn't been checked. Okay. Okay. How long is this? How long am I going to be doing this? It's +2, Jesus. All right. Actually, is this the last function in the sequence? It might be. Non-standard but logical. Non-standard but logical. Yeah, so I'm in here. This is probably what's causing me issues. Yeah, non-standard but logical channel. I guess this here. So it's trying to do, because my stuff only has a single channel. Yeah, so maybe it's doing this because of that. And that's an else statement. There's that part. My guess is that the last section of this where's I right now? It's gonna be a while before I get out of here. Okay, let's do next 50. Wait for that to finish up. Okay, so you can say how many times you wanna run next. Really helpful. 40, 50, 54, print. I'm not gonna do the math. 64. Cool. So 960. Let's do, if that one bumped me from basically 50. Oh yeah, 50 iterations. That makes sense. I need let's do 800. Yeah, let's do 800. This is where we wait a little bit. Let the ST-Link V2 do its job. Just stepping through my code. Man, this might take a while actually. It's kind of annoying, but I guess I'm doing something non-standard, so if there's some code that's gonna break in this thing or be a problem, it would be that. Interesting number. I wonder why it's 15 times 64. It's used everywhere here. That should be a constant. Should be a set of constants. Could be a set of constants. Yeah, I wonder why 64? Must be like how all this stuff works. What is lens? It's a float. Oh, jeez. Man, I didn't realize we're doing all this floating point math. It's a good thing I have an FPU, otherwise this would not work very well. Jeez, we're still waiting. I actually don't believe that, I'm starting to believe that maybe doing MP3 decoding directly on the MCU, trying to shove it over to the DAC, is just not going to work. Especially because, yeah. But that's why we're trying it out. All right, so let's print I, 800. Okay, so we're getting close. Now we know that's just looking at add. We can just do another 50, which would get us to 900 something. All right, print I. All right, I'm this far. I'm gonna check to see if anything's happened with the, ooh, okay. All right, so somewhere in there, we have overwritten the stack. Okay, let's put breakpoint here. On, reset, halt. Let's go back. I don't know what's, oh, I'm just kind of confused. Why are you having a conniption right now? Thread 1, thread 2 decoder stopped. We have a failure here. All right, let's get out of here. Let's get back in. On, reset, must have faulted at some point. Crap. I can look at it directly from here though. All right, so we need mini mp3.h 1648. Mini mp3.3.h. I forgot the number. 1648. 1648. And let's go. Cool. Layout split. And the first thing I want to do is kind of iterate a little bit. Cool. And now I'm going to do print. I'm going to print. Let's do that little thing I did last time again. We're going to cast the stack pointer to a E132. We're going to look at that. That looks good. I'm doing Control X and then I think it's Control X O. Yeah, Control X O in order to move windows. I just became natural at this point. I forgot that I've been doing that. All right, what in the world is QFM state? Okay, let's also print lins. Okay, these, yeah, that's the MP3D thing that we like, some object that we create, and that's, I believe, just that's not on the stack. This right here. That should be on the stack either now. Neither one of these are on the stack. How exactly is this particular function? Let's look at I haven't been looking at the assembly for it, but what about this could eventually end up hitting the stack? You know what I mean? Like, how exactly is the stack pointer's value getting touched by any of this? Let's actually do print nbands times 64 plus I. Actually, print lins plus nbands times 64 plus I. Okay. When I becomes 15 times 64, wait a minute. Wait a minute. Where's lins? Where's lins defined? Lins. Lins was passed in. How's lins passed in? Granule. Scratch. Where's scratch located? Scratch. Oh shit. Alright. So scratch is some struct named scratch. Oh shit. How big is this thing? Oh my goodness. Oh my god. I need more stack space. Nah, it's just Stack Overflow. That's all this is. Oh damn. I don't know. 5,000? How big is my stack size now? That's not what I want the decoder. 20K of stack size. Yeah, I think I'm gonna need that. I should. There's a way in GCC to give you like the estimated stack size for everything, and because all these things are like easily well definable, it should be like easily able to be figured out. I'm actually just gonna put this out here. I'm just curious. A little another trick that I like to do: const expr size t. Let's put size equal to size of, and then I hover over it using claim D or whatever your LSP is. You gotta be fucking kidding me. 16,000? Just putting that on the goddamn, sorry, I shouldn't be swearing. Putting that on the stack? Oh my god, no wonder I was crashing. Oh my goodness. Yeah, no, yeah. Oh my god, so much stack space required. Awful. So that's 16. I don't think anything else I do. So 20, I have 4K for everything else. Yeah. Or 4K for any other additional depth that might come from that particular function call. Wow. All right. That's probably going to solve my problems. I guess, yeah, the answer is simply just to increase your stack size. It almost always ends up being the problem whenever you're using an operating system like FreeRTOS. If it's breaking out of nowhere in a random spot that wasn't doing that before, you probably need more stack size. Let's load this up, and we'll see how this goes. I'll turn on the speaker. I don't think anything's going to play. It's probably going to sound absolutely awful. That's just the sound of my speaker. Don't think that's, my audio playing. Not yet, at least. All right, so I'm gonna put myself on a breakpoint in audio decoder. Jump on in there. Turn off the D, do some other stuff. Decode frame. Do I survive? Oh, let's delete that. Oh, goodness gracious. Info B. I'm at breakpoint 1. Info B. Yeah, breakpoint 1. Delete 1. Damn. Finish. Looks like we're good. We're doing great. Beautiful. Okay. All right, well, press go. It's gonna sound awful, I bet. Holy shit. Oh my god, it works. Oh my god, it works so well. Holy shit. Oh my god. Okay, hold on. Oh my god, the theory worked. Oh my god, I had to put it into a different RAM chip, and that's all I had to do. Okay, so delete this guy. I chopped the MP3 down. Unfortunately, this is not royalty-free music, so that's unfortunate, because this is a pretty cool thing. I might cut this out later on. How do I do this? I'm going to delete the build folder. Don't delete the build folder. Change your code some way. This works now. Okay. All right. Let's load it. Oh my god. Oh my goodness. All right. That means we need to consider this for the PAL. We need to consider where your memory is being used for your DMA transfers and all of that. Let's see how long the transfer's going. My goodness. That was the problem with my DMA before. I was using memory on 2 SRAMs, and if you know anything about DMA, DMA is going to try to access your SRAM, and your CPU can't access it at the same time. So if they are in conflict with each other, that can be a problem. Now, a lot of times, it's not a problem when your data doesn't need to be super real time. Like if you're just storing stuff into an SD card, it doesn't matter that much how long it takes. But when you're trying to be real time like this, and you're constantly streaming out data very quickly, yeah, that could be the issue. So let's see if this freaking works. Let's freaking go. Oh wait, I don't know if this is the same one. It's debug. No, it sounds like the home song. Oh my goodness. That works. Oh my goodness. Well, I'm happy, and that's cool. That's the end of this little demo, and talk to you guys later.